Okay, so again, welcome to second week. Today we'll start with the FEA analysis. We would go with the topic mesh convergence and mesh control. So we will present the default meshing. The software already does set it up for us, and we just click run, and then we will adjust the mesh to coarse and fine mesh studies. And then we'll have a control mesh to show you how can I save my time to get the same result with less, we call it expensive computer running and time. And then the last thing, fillets. We use fillets, which to make it as a curvy radius for some of the designs. If we remove them, how the results will look like. Is it good to keep the results? And at the end, we'll have tiny quiz. No marks, it's just quiz to test us. Have we learned what we did today? And go through it. And this presentation will be available as well with the materials. So first of all, I want you to select to open SolidWorks and a new part. From new part, be ready with the right plane. So SolidWorks, give you time. So start from the origin point, but first start in SolidWorks. Right plane. So we need first to draw the part. So it's kind of like revision. What we learned from drawings is just revision for the SolidWorks drawings. So you start with that new part, call that part the bracket, or we can save it later. And then click on the right plane, and then from right plane, make it to face you, to front you. And then under that, start with a sketch. When you start with a sketch, you will see that the center, the origin is showing in the middle. And what I want you to do with the sketch is to start from the origin point to sketch following these dimensions. So start from origin, go with a straight line upwards. The units is millimeters, 8 to 2.5 millimeters. And then you go from that point and follow the dimension. This angle, 40, it's presenting that line. And that line should be that distance, 42.76. And if you need help, just call me so I can go with you. So right plane, and then sketch, sketch, create sketch. You activate sketch.
I understand it. You.
And then from the sketch, try to duplicate the drawings. Take your time. Yes, if you have a question. You need to start sketch. Click on sketch. And then you start sketching lines. Select lines. So right plane face you, click sketch, and then you select line. So all this drawing by a line. You start from the origin, you go up 82.5. Make sure you set up yours in millimeters. Your units at the corner. And then left. That one, don't close it. See, it's missing dimensions, so leave it till the end. You go from here to there, 44.45, and then you sketch a line. Make sure that will go with an angle of 40 degrees with a distance of 42.76. Leave it here, and then go back from top. And then when you finish, you connect these 2 points to close the diagram. or the sketch. I prefer always 2 dimensions and don't do the sketch. So every time you sketch a line, dimension it, but don't close the sketch. Just sketch line, dimension, sketch line, dimension, all should be under one sketch. So again, my advice for you, always when you sketch, add the dimension. So when you start with this line, quickly add the dimension. When you go that way, add the dimension. So you create the relationship between them nicely. Done it? It's that angle. You need to show me that angle. So the angle between that line and that line should be 40. If not 40, then something in the dimensions. So you select that line first. This one? Yes. And then that line. Same time? Yes. And now you're saying that's the angle, but you select not that's the wide angle. Kind of like you need the relationship to match the small. So that is the distance, that is that 40. So that is should be 40. So if you do the entire angle, should be 40 plus 180. Yeah. So if it's not 40 plus 180, then it means that is not the right distance. So you can put it that one to be, you can type equals 40 plus 180. Because the dimension can accept equations. Yes.
After drawing this line, can I give the angle?
Yes, now you give the angle. Dimensions. Yeah, you select that one. And the line. The line. And that one. So you disable the dimensions. You need to activate that one, this one, and then you count. So that is wrong, it's 45. You need to make it 40.
I can edit it.
Yep, you did it.
Okay.
The angle, not 45. It's a good practice to show you, like when you get the application, you want to sketch it.
Which one? What dimension should I get? What dimension?
How do you check it? Like if you have all the dimension correct, that's fine. Yeah. The check is 31.16 is correct. Yeah, you got it right now. Yeah. So just wait for it. And is that one?
Yeah, that's what I have to get that.
When you have that situation, you can always sketch what we call it disconnected line, which is center line. So right click on that line and properties, you can change it to center line. Center line, it's mean right click on it, like you have here, or click on it. Here you can for constructions. That is mean, click on that, you haven't clicked. Now tick. Yes, that line is became as a center line, which is for construction, is not for drawings. If you want to do that relationship, But if you keep it in line, you need either to trim it later or delete. And if you delete the dimensions. But you can do it without that. So I'll show you how to do it without the dimensions. Good, you got it. 40, perfect. You got it?
Yes.
Right, so all of you got that dimensions. Now we need to extrude. So what you do, you accept the drawing, or you have the option to straightforward to go to use boss extrude. So you go to features, and extruded boss face, click yes. And then we'll ask you the question, what do you want to do? You select it to be mid-plane, and the dimension you add is 38.1 millimeters. So similar to this one. So you can see on the screen, direction 1 is mid-plane. The D1 is 38.1 millimeters, and that should be activated all configurations. Mid-plane is mean going from the center, half of 38 that way and half of 38 that way. So we go the middle from both sides. If you don't choose mid-plane, we'll go on one way, either right or left, depends on your directions. Okay? So it should be mid-plane. You don't need to change the text as the text is already selected, and that value is 38.1.
I don't have the configurations.
That's fine. Possibly I'm using a new version. Yeah. Cool. Yeah, it should be something like that. If your geometry, when you finish it, when you do that, what will happen? You click OK, which is the tick. OK means that right green tick. And then you converted it technically to a 3D mode. Are you all there?
Yes.
Yeah. Except maybe Haritha. Are you there? Okay, good, perfect. Now, next step. We want to remove, see, that's where it gets a lot of interesting things. We need to use shell. So when you go to features, you will see a command called shells. Shell, search, be familiar with it. More, move, yeah. Shell, click on shell. Under shell, using the shell to cut through selected faces from the part. So what we're trying to do, we want to shell some of the faces and we go through it. So first, the parameter for shell, it should be D1 6.35. So put that parameter in shell instead of 10 millimeters to 6.35 millimeters. And must be shell outwards. Tick that one. There is a box, shell outwards. Now we need to select the faces. So I'll tell you which faces. 1, 2, and 3. And there is a fourth face from the other side. So, and this. And then turn it from the other side. You select that fourth face. So again, 1, 2, 3, and you turn it for the other side. Okay? We haven't selected the down, make sure for it. What will result for you when you click OK? The green, something like that.
Yep. Yep.
Click OK. Perfect. So now we converted that kind of a bracket using the shell command. Okay? We all there? Good. Let's move to the next step. Fillet. Fillet is used because we want to, instead of having those sharp edges, to convert them to edges. So go to features. Under features, search for fillets. You find them very nicely under the option where you find the shell. There is the first one on the shell. Where you find the shell components, there is a fillet. That's shell. Where you click on shell? Fillet. Wow. Yeah. Click fillet. Under fillet, I'll tell you which edges, but before edges, we need to set it up to symmetric. The value is 3.175 millimeters, and the profile is circular. Those are your options to select. So, by the way, you can also click full preview so you can see it before even we accept on it. And I'll tell you very soon which edges, but first we need to adjust the values. The value is 3.175 millimeters. That's the radius we want to fill it. Symmetric is and circular. If by default there, keep them like that. Don't change. I mean, keep the default. And then you can show selection toolbox, tangent, full review. Now, which edges I want you to select? 3 edges. Look carefully to your drawing. Edge is not the face. Edge is a line. Edge 1, edge 2, edge 3, the inside of the brackets. And please, is edge is mean the line? So 3 edges I need to select. When you click the preview, it shows you in yellow lines, this is how it will look like. Yes, that's the 3rd edge. Perfect. Happy, click OK, which is the green. You will get a curvy edges from inside.
I select only here.
No, you selected face. See, when you say face, you select edges. Edges is different from face. Edges is just the line.
Now I
So
need to select
remove selection, clear selection, right click.
here.
Yeah, clear selection. You need to practice more on SolidWorks, okay? Otherwise you'll be behind others. And then you select the edge. That's not the edge. Okay, so which one? Just move. So when you come here, first you need to turn it out, and you can see things better. So that one. Oh, you cancel it as well. Should not cancel it. That one, that 2. But now because we have a big value, because we cancel it, it's going to that way. And then you change the values. So put that value instead of 10, put 3.175. But you really need to train a lot. Yeah. Have you been practicing last week on SolidWorks? Yeah, you need more. Okay. And then 3.17 circular. Yeah, click OK. All right. So that one is done. That is the first fillet. Now we do the second fillet, which would be for the outside. So second fillet, you choose again fillets. Go to features, fillets. Now what we set up, the dimension will be 9.525. So instead of 10, it comes by default. And then we select 3 edges. Which edges? The outside. Edges, not faces. That edge, and that edge. And because of the full preview, we can see them. Not the face, yeah. If the face selected, you just right click and remove and delete. Clear selection will clear everything. Rotate it. When you select the edges, rotate the geometry so you can have a full control of what you're trying to select. Don't restrict yourself. No, be flexible, rotate it, and happy with that. Yeah, if you're okay, click green tick, the okay. Now you generated something similar to that, which is very fillets, and that is very common. We go through. All good?
Yes.
Now we use cut extrude. Here is a bit tricky. By the way, I'm making you to do this by your own. I can show you in demo, but you. So what I'm trying to do, I will sketch a circle on the top flat surface. And you should see the dimensions. And this required more attention here. So we want to sketch a circle on that. So remember, you have a flat, curvy, and that we're going with an angle of 40, if you remember. Now that on the top, select that face, and we'll be giving you that blue color. The top, the face from the top. Rotate and select that top. Yeah. Now, when you select that top, you can click now on sketch. Sketch and sketch. Now it's allowing you to sketch a circle. The circle should be with the following dimensions. The circle for it is 12.7 in millimeters. That's the diameter. Phi is diameter. Now, where is located? This is the critical. Should be a distance, the center for that circle to that line, it's, my eyes are very bad. 19.05. And it should be at the center. So I'll give you more information and hints. That's better. This is my origins. Remember why we did mid-plane, why we did the origin? So my circle should be always with the origin. And that origin from that edge, which is that edge, it's 19.05. And you can see it here is better by giving you different views to see it. You need help with this one, call me. I can show you how to adjust it. So first, put the diameter, 12.70, the diameter for the circle, and then centralize it with your origins and the distance. You can see it from this center to that edge is about 19.05, and that is the center for the circuit. It's in the mid-plane. By the way, you can repeat this step. If you started wrong, just erase it and resketch it again. Stop. Bad deal.
Keep it straight or?
Yeah, keep it straight.
Oh, no, I was looking for your picture.
You need to select the surface where you're sketching, because if you haven't selected the face, then we'll not know where are you sketching. Yeah, and now sketch. Yeah. Now select circle and follow the center line. Yeah, go down and put it somewhere. Put it somewhere. Yeah, and then sketch. Yeah, close. Put the dimension. Smart dimension. Select the circle. Give that value of 12.7. Click OK. Now the distance, give another from the center. So choose the center to that edge. Yeah. Move in the side. Give that distance of 19.05. Good. You got the first circle done. And if you want to use lines to make your life easy, make them construction lines because you get them better. But try to learn how to use the center so it can move you with that, because the mouse can sense the center line and then that disconnected line to tell you, hey, you're on straight line, straight line. All right, all of you made the circle or still we have one? What's happening? So select dimensions, select the center, go to that line. That line, yeah, you were there. You were just there. Why we switched off? The center and that line, and then move. Make that is 19.05. Because you draw a line and you create a relationship and doesn't accept it. So delete that line you draw. Now go smart. Select the center and that one.
Well, it's not.
Yeah. Okay. So what is telling me that you created a relationship here that doesn't mean it's that relationship. Please remove the shadows and all these real view because it's annoying like this here. So you created some restrictions for the center we're drawing here.
437, 511, we had some issues with that. The reason so sorry, me and sort them out there, we've got ownership of it. But I got some good things about that. Yeah. Yeah.
When you add restrictions to it, it makes it cannot be. All right, so now what I need next step. Are you there? Yes. We want to cut through. So you go to features and use the cut extrude feature. Cut extrude, you'll be similar to the sample. You can see it at the corner. Cut the corner there. So features, cut extrude. What you want to cut extrude, you use the following up to next. This is what I want you to do. Up to next. And that's all. And you click OK. What will generate for you? The following shape. So up to next is mean we'll make that hole in the brackets only for that part. It doesn't go. If you tell it go to the other surface or other option would go through that. I didn't need it to give it the dimension. It's just say cut from that surface to the other side of the surface. So up to next. Right. Any questions so far? We're all good there? Done. Save that. Call it bracket. Create a folder first. That folder inside it, call it bracket, because that folder will get big. So you must create a folder. Don't save it on desktop or anything else. As an own file, create a folder. Inside that folder, call it a bracket. All right, saved. We're good. Again, create a folder, organize. I give you time, no rush. I give you time to organize your files. Filing is one of the most important things in this paper. You need to really create the files. You remember how to find them later. If you miss, you'll get them too much things. So manage them nicely and call it a file. Week 2 examples, mention convergence. And when you're ready, just say I'm ready so I can move to the next task. Ready? Good. I'm ready. Still, yeah, take your time. Just make sure to have everything saved because we will go back to it. I need to explain theories first, and then we continue on that example. Ready? Ready? Shivam? Again, my advice for you, please practice every night. I will send you a good YouTube videos done by, they are available online to do big projects. If you spend remove those, go to remove, then you come to the screen here. Yeah, and take real view and graph view. Okay, and the other one to show us. Shivam, ready? Are you ready? Yeah. Okay. So now we talk about the FEA analysis. So first we will just talk about them. Later we show you the demo. So FEA analysis will require us to do some what we call it using the add-ons to activate that on SolidWorks. I'll show you later how we do it. And then we will cover today the topic is called statics. The aim to improve the mesh, such as adding control area in areas of high stress. So you have this example. You can see at these edges, the mesh constraint or the stress concentration is not really best illustrated. We can increase the mesh and we make it better. So it means the study will solve more points if you increase the mesh to find more accurate values for the stress. How it looks like similar. So instead of increasing the mesh for the entire body, we just increase it where we think there are areas of high stress concentrations. The reason we do that, technically we can tell the software, hey, there are parts of this geometry I'm not really worried about. They are solid and strong to cope with the material. But this circle, which I predict there will be the weakest points, more stress is applied to it, I can control to add more study on it on the respect to mesh. And then if the mesh control decreases in size, maximum stress values is more accurately represented. You get something similar to that. To achieve that, we repeat this process multiple times. Repeating this process, we call it mesh convergence. As the element size decreases in area of high stress gradients, the solver will produce maximum stress values closer and closer to the true value. If my mesh is not really fine and using some techniques, then I may end up with the results. You can compare it here, see the original mesh results, how it was the stress concentration, and this is the most accurate one. Because here it was used some default techniques set up by the software. Here using a refined technique using mesh control. So mesh is very important. Technically, you're telling the software to do the integration to solve the problems in the small problems and find the stress concentration and distribution along the geometry. So we have two different types of meshes set up by the software: coarse mesh and fine mesh. And the things we will learn as well, how can we combine between them using the mesh control? This is the example. Coarse mesh, you see it very clearly. This is for the geometry we'll do today. Fine mesh, it's more small elements. Combine and control, you see, we only focus at the edge of the fillet because we believe this is the weakest area and we want to see what will happen to it. How do I know that? Because the initial results tell me the maximum stress concentration occurs at this. So technically this for me is one of the weakest location for if that bracket will break. And then I focus on it and more to reduce time and concentration. So the software, when you go to mesh, by default, always when you start it, showing you that option. It's in the middle somewhere. If I go and bring that to the chorus, will be chorus mesh, we give you something like that. If I bring it that way, we give you a fine mesh. But then we can leave it there. We can adjust the parameters to use control mesh, which is later today we'll achieve. And then you get the difference. See, that's the results for them. Here is showing you where is the maximum occurring. Here, when it shows the maximum, but with fine mesh. Here is showing you if we apply a control one, we can actually get the same result with less time waiting. Now, the other things which we'll learn today, if I remove the fillet, you remember we did a fillet, internal ones? If I just wanted a sharp edge, it's not a good idea. What will happen will give us the wrong results. Will give us infinity answers for it. See, I lost that concentration. So it kind of tells me, no, nothing is bad here, but that's not logical. Because we know this is the weakest area where we predict the break to occur of the material to fail. Okay, so that is one of the things we need to be as a FEA analysis to understand between them. So an example, before we start our one, the one I don't want you to close because we will use it very soon. Let's explain this in more things. You get a 3D part. We do the coarse mesh, less elements to solve for stress distribution to save my time to just investigate. And then the simulation study produce a rough stress distribution with a maximum 2.3 megapascal, 2.32, extending down to the material. And we know this is the weakest area here. Now, I use the fine mesh, means more elements available, as well many more Gaussian points, which I'll tell you what is Gaussian points used by the software. That means the simulation study produces more refined results with a maximum value. We shifted from 2.3 to 2.7 megapascal, can more accurately pinpoint stress in the part. So what is the Gaussian definition for it? I wrote it in the notes here. 1 second. I just wrote it for you. In finite element analysis with SolidWorks simulation, Gaussian points, often called quadrature points, are specific location inside each finite element where numerical integration is performed. This integration is essential for accurately evaluating the internal forces applied on the geometry strain, and stresses within the elements. So kind of what you studied from Moore's circle, if you remember in strength of materials, that's actually studying the stresses in the X, stresses in the Y, and shear the tau stress in X, Y. But in Moore's circles, you were doing it in 2D, X and Y. Here we're doing it, the computer is doing it, not you, in 3D. So when I say in 3D, what do we mean by that? We'll go through the default. So let's start our scenario. Now, you go back to your model, part EA. I want you to give it a name. We already named it. First of all, go and check if you have the simulation is ready. Yes, simulation is active. Go to simulation. No, you don't have simulation. Simulation is active. Go to simulation. Okay. Go to simulation. First of all, I need to make sure like you are on simulation. Simulation. Okay. And from simulation, go to study and make a new study. By default, keep that one as a static study and click yes. Okay. Call that static study. Call it default study. How do I name it? Go under and double click on it. Name it default study. So when you see the bar underneath, double click on that. You can name it default study. So do you see that static one? Double click on it. And call it default study. You done it? No. Yeah, you can call it from here as well. And tick OK. Okay. So you can call it earlier, or in case I forgot, you can amend it from that one. Okay. Now, what is generated for you? The following parameters. You have the default study. Do we have the material properties? Not yet. So what is saying for us? Bracket material, choose from alloy steel. So where is the bracket? Right click on the material bracket, the blue one. Right click on it and then apply edit materials and find the material alloy steel SS. Either you find it or search for it. Search for it is faster. You can find first. So right click there, bracket, right click, apply edit material. And then you have on top, you can search alloy steel SS. Remember, be very specific, please. There is alloy steel and there is alloy steel brackets SS. Specifically here is very important. If you miss, you miss. Good, you find it. Apply and then close. You find by default will show you that the brackets in brackets is the alloy SS steel. And that's why I'm saying to you, you can say, oh, it's alloy steel. No, be very specific. Now, fixture, what we want us to do. Use right click on features, and use fixed geometry, and then select the internal surface of the circle, the inside surface. And then that will be fixture. By default is fixed geometry, entire surface. You can see the selection when you select it there. Yeah. Yeah. And then happy with that, click OK. I'll check everyone, make sure. No, that's not the circle. Yeah, you select the surface, the internal, yeah, inside surface, yeah. But you selected the other face, delete the first one. Okay, and now click OK. When I say click OK, it means that green tick. Now, external loads, right click on loads. So external loads, right click on them. And use force. And then we'll ask you, what do you select? You select that face. And you add the value of 900 newtons going downwards. You make sure the arrow is indicating downwards. You add the value 900 newtons and then click OK. So what we've done to solve this problem for engineering, I need to know the material properties. because it's using Young modulus, the elasticity and everything. I need to know where it's fixed. This bracket is fixed from the, like a screw, let's say it screws to the wall as an example. And I need to know the load is applying to it. How much load is 900 Newton? This is, by the way, is not point load, is UDL load, uniform distributed load for that surface area of where we apply. If any question, please feel free to ask. What's next? So that is all. You've done that. Cool. Now, mesh. Double click on mesh. Or sorry, right click on mesh, create mesh. When you create mesh, you find by default is standing here. That's, we call it the default. Don't do anything, just click OK. Because that's what we call it the default study. Okay, now you see it's generated for you the mesh for that geometry. That is called the default mesh. The software just in somewhere decided that is the default. Now, if I want to know this table, right click on mesh and find mesh details. You will get a table like that one. What is telling you? The detail of the mesh type is solid mesh, standard of element size. That's the element. So that bracket is divided to element size of 3.83 millimeters. Tolerance between them, the height, the mesh quality, total nodes, total elements, and all the information, even the computer name where you are. This is very important because it's telling you how much information about your mesh. Okay, all we done this, you go next step. Run the study. You can go either run this study, you can see it on the bar, and follow one thing. Have you saved the files? Just right click here. So, I click. Run. Unable to open master control file. Define the problem. Use character supported by OS. Oh, you haven't done the fix job. You have a fix. Don't save it. Let's save it brackets. You give a weird name to it. 14. Please don't add weird names to the files, like a date or numbers. It must be named as a bracket or something. So when you name your file, avoid these names, brackets. So you don't search for it as 2025. It's engineering, communication 101. Do they teach you that in engineering communication? It's very important you have the brackets because you can call it and you can see where it is. Okay, you can call the folder week 1, but not the material. Okay, so stress von Mises is in SolidWorks. When you run the results, you can click on stresses. That technically calculates von Mises for you. Now, if you double click on von Mises chart here, you can convert the units to be megapascal. So double click on it. And you go to definitions. And then under units, change it to megapascal, which is between brackets. And then click OK. And that will show you the numbers in more. If you want to show the numbers floating, you get through. So what is showing you here? The design for that alloy steel SS yield strength is 620. Your maximum stress is 118. So we never exceeded the maximum allowable stress. So my design is safe. And what else? So if you want to get rid of this +2, double click again. Double click and then go to that. Instead of scientific, make it floating. And then go and tick OK, and that will change it to a right number. Okay. So
SolidWorks is a single scalar value derived from the full 3D stress state that engineers use to assess whether the material will yield under load. In other words, it combines the different stresses components, normal and shear, into one equivalent stress. This value is compared to the material's yield strength to predict failure in a ductile material. For example, in SolidWorks simulation, after the finite elements analysis computes the stress at various points, typically at the Gaussian points, which we described before, the software calculates the wall mesh stress using this equation. So what is have stress 1, principal stress 1, principal stress 2, principal stress 3, and they are calculated similar to Moore circles, but instead of one that way, there is one coming towards us. So 3-dimensional principal stresses. And this value often displayed in stress plots helps you to determine if where your design may be started yield or fail. Who is deciding that? You have the yield value by the material you selected. So the software brings that from the material properties, and it tells me I haven't exceeded it. If that arrow shows here, it's mean my design is failed, will yield. Will yield is mean will lose its material properties and break that bracket. So with this design, with this 900 newtons, my design is safe. But I have a problem. This value is not the accurate one to the true value, because I use default mesh. And that's why. Did it work for you, Harita? No? Yeah, avoid naming it that way, okay? All right, so what do we do now? Check the other one, the displacement. Double click on displacement and the results. Double click. You see that the result will show you displacement in millimeters for it. The maximum displacement for this design for me, 1.25 millimeters. And you can check the other one, which is the equivalent, or yeah, there's a displacement and there's stress or strain. You can click on that. Right.
After displacement.
Strain, you can click any one of them just to explore. All right, after displacement, we want to make a new study. Okay. So you go back to that bar, the bar under, you know, where is your SolidWorks says model 3D view motion. We created that bar, right click on it, copy study. Under the bar, under, where is the name? Under. Right click on it, and you say copy study, the first option. All right. So when you copy study, you name it. You name it chorus, you do twice. First one, call it chorus mesh. Okay. And then do the copy again and call it final mesh. So we're creating two studies from the default one. Copy and then change the name to be fine mesh. So technically, that bar is telling you you can switch between them. You switch between studies. You can do multiple studies at the same time. And don't do anything yet. Don't run, don't try anything. Just create chorus mesh and then recopy the study to call it blind mesh. So you have default chorus blind mesh. 3 studies on your bar to switch between them. That is useful because when you do optimization, you don't want to reinvent the wheel when it's already designed. You just copy. Okay? If you're there, just let me know so we can move to the next step. Yep. So those are the things we want. Now, go click on chorus mesh study. I want you now to activate chorus mesh study. Chorus mesh. Okay? Chorus mesh under mesh, go and click create mesh. Move that to the end chorus, the arrow. So next thing, we shift that bar to go to chorus.
and then we click OK. Okay? Still there, don't do anything. Follow me step by step. Now you get the mesh. As soon as you do it, the software will create you that chorus mesh, which is really very big elements.
Mine's created small mesh on fillets.
That's fine. That's not bad. Yep. Still, we haven't done the control on it. Possibly you have the new edition. Trying to. Now, go to the other study, which is the fine mesh. So click on the fine mesh till you see the fine mesh is active. Repeat the same thing and move that cursor to the fine, to the end. Then when you're happy, click OK. And then we'll take time, a bit longer than the first default and the chorus mesh. It's not too long, but slightly longer. You feel like, oh, it took us a bit more than the others. And then you will get the mesh like this one. Oh, good. You're doing the chorus here? Yeah. Chorus. No, you're still on chorus. I see it's active chorus.
Yeah, I did that.
Yeah. No, so we are still there. Go there. Go to mesh. Right click, create mesh. Yeah, and then click. OK. And stay there. Don't do it. Okay. Just follow instructions. Don't jump. Okay. What's next? Run the study. But because I have two studies, so instead of run this study, there is an option under run the study. It's called, when you click the arrow, run all studies. You see that on the screen? So now I want to run them all in one go. So run all these studies. Now it takes time. We'll run for you chorus and fine mesh studies. Now what it appears to you will show you a dialog box similar to this one. Have you got this dialog box? And it will go and rerun default study if in case something we have made changes to it. And then we'll run the chorus and then we'll show you here like kind of like I'm doing my calculations, leave me alone. This is very helpful if you have multiple studies. Shivan, are you with me or you? Yeah. Have you done the meshes?
I've done it first on the fire.
Where's the fine mesh? Click on it. We open the motion study. Yeah, please just follow the instructions. Don't try things without the instruction till we finish, and then you can try your things. Okay. Wait for Shivan to finish. Okay, do the mesh, change it to fine. Okay, okay. Right, to finish. Funny, it's not even showing the mesh. You click OK. Okay, then go run these studies, put the arrow down, run all these studies, No, I just continue. The thing is, it's not usual in your computer. It's really run. Okay, I'll continue and then we'll catch up with you.
Who's taking? Oh, someone is from.
Wait is there. Hi, can you hear us?
Oh yeah, yes, I can hear you.
Yeah, good. Just be aware we are recording the session. So if you missed a lot, you can catch up with us later, okay? But you
Okay.
can stay with us, okay? So the
Cool.
session is on
Yeah.
record. Cool. So now when you run these studies, we can compare between them. So for Chorus Mesh, you can click on Chorus Mesh every time you switch from study to other study. You can see the difference between the stress concentration. So for Chorus Mesh, we reached to 109.29 megapascal. For the fine mesh, we got 141, which is closest to the realistic one. So I took the images here, but you can switch between them. And every time you go to the results and you go through them and you compare between the values.
Mine, it's not quite the same, but it's, I think because it generated fine mesh
Yeah.
automatically for me.
And that's again depends if you're running it on the cloud.
Yeah.
Just to let you know, if you run this on the cloud, it will give you different results. So have you got the result for that? Yeah, you can get double click on stress. I can't see the result. Okay, good. That's good. That's good. Now do the run for the Chorus Mesh as well. So that is showing you if I use a really not really good mesh, I could really get the difference between 109 to 141 is a lot. And for my design, to me, I need to be more accurate because if I'm giving this to the industry, they may say, hey, you tell us this bracket is safe for 900 newtons, but if we, with your design, I still have flexibility, I can add another 100 newtons to be 1000, and then the brackets will break down for them because they thought, oh, it's 109, you told me the maximum. So I'm far away from what? From the yield. So the yield is 620.422. So I can add more to it, which we do as a human. You know, we always try to add things extra by nature, but you need to make sure to take the factor of safety and other components in it. All right, so something I want to check: number of nodes, number of elements, and the total runtime. So you go to results, right? Click on the results. Results. And click and find solver messages. So, you know, I'll show you the demo. So if you don't know what I'm talking about, results is here, the one we're showing the results. Right click on it. You click on like an envelope, say solver messages. You can do it for the default, for the chorus and the mesh. And that will tell you those messages. I went back to each one of them. It tells me the number of nodes is 3072. But when I did use a fine mesh, the number of nodes increased to 84,000. And the number of elements from 1,626, I increased it to 54,000. So technically, I converted that bracket to more small elements. And that elements, what we talk about is the quadratic Gaussian points, which the solver trying to solve using the integration methods to find the principal stress 1, principal stress 2, principal stress 3 to get me my von Mises stress. So that is technically, and also will tell me the time used to do the simulation. So the first one, chorus, is almost 0 seconds, while the other one, 0.4 for the second, smaller. However, this is a simple application. If we had more complicated, it would take minutes and then hours and sometimes days. So that is good for you to compare how much you have achieved between the two designs. This means that creating a fine mesh at the location of stress and concentration helps identify the true maximum stress value. By the way, the true values was never actually reached, but this concept of mesh convergence means that as the mesh is made finer, the study results get closer to the true value. In FEA, we tolerate an error between experimental and FEA maximum 4.5%. More than that, we question marks. Like that's for industry, for research. For study, we're okay with even 70% error. But in reality, no, that's too much. I mean, your results needs more refinement. Okay, it's not much left, and then we sum up everything. Mesh control. So instead of using fine mesh and making everything small, we can just focus on few things. Why we need to do everything? So we can use the mesh control. So copy the default study and name it local refinement. So go back to the default study. Again, click on it, make sure it's active, and right click on it and make copy and name it local refinement. Have you named it local refinement? Because you haven't copied it yet. Have you copied? Then right click, copy study, and call it local refinement. Change that name. Local refinement. It's kind of, we want to do it. And this is very important because when you come and I check yours, I know like this is chorus mesh, this is fine mesh, this is local refinement mesh, this is the default mesh, these studies. Okay, now recreate the mesh. To recreate the mesh, you just go and leave it to the default. So go to mesh and right click, create mesh, and click. Don't change anything, just click OK. And then we'll create for you the mesh. Not changing, okay? Now, under the mesh, go and find apply mesh control. Right click on mesh and then search for apply mesh control. You can see it on the screen. And then from there, you will do the following. You select the fillet, the face you want to apply refinement, that internal fillet. You keep that value of, you can see it in the chart, but you change the 1.4 to 1.2. So keep that value on the top. Now that stays the same as a default. You change the 1.4 to 1.2.
It's 1.9.
Was 1.9 something here. Okay. Now, when you're happy with that, so technically you just change the 1.2, the ratio to 1.4 to 1.2. Just that goes to 1.
It's different. Oh, you select an edge and the face. Just select
1.2.
just the face, not the edge.
Yeah, choose the fillet, the face. Yeah. Okay. Now click OK.
It's different.
Yeah, they're using the old version, slightly different. This is fine. You click OK. Now run the results. And it will take time. And now you see what was happening. Comparing to the default study, which we had 1 point something, 109 megapascal, now we got 141, close to even the fine mesh, with less efforts, less elements, and less using computer timing and stuff like that. So do you see that? Now we use a smart way to get better enhanced results with less time. Less energy on the computer and the processor and everything. So that it's come with 1.38 for me or 39, but for you will come differently. 1.39.73 megapascal. However, the fine mesh study shows 141, so we got even better. So it's like, can we do more refinement? Yes. Let's try again. What we do? Go again back to control mesh. Now we have it. Under the control mesh, open that icon, which is called, so open the control mesh, extend the arrow, and right click on control 1 and edit definition for control 1. When you click on edit definition for control 1, change the value. Now the one you Jason changed before, instead of the ratio 1.2, change that elements to 1. Instead of 1.9, the default, change it to 1. And click OK. So we're reducing the elements. Done it?
mesh control, click on the arrow, the arrow. Right click on control, edit definition, change that value to 1. Then click OK. And then run study again. Because if you see that is not run, it means it's giving you the triangle is meaning this study is not run. What you get, the maximum stress for me is moved to 145.43. It's better. Again, less time. I didn't need to bother with my other components. Now I can redo it again. So what I'm doing the convergence. I change that value instead of 1 to 0.7 millimeters. So repeat the steps instead of 1 millimeter. So keep that ratio 1.2, but change that value to 0.7 millimeters. And rerun the study. Shubham, are you there or still? You mean you go?
No. Take change in the
So why are you starting? We're still here. Why are you starting a new one?
Oh, I thought that.
No, we're doing it all. We're just going to mesh control. Have you done your mesh control? Where is the mesh control? Click on the extend that arrow. Right click on mesh control. Right click. Edit definition. Change that value and say, so that should be 1.2. And that one now made it 0.7. So, yeah, because we restricted something. Okay, click OK. And now run the study. Yeah, then you get it that way. So that is mean I'm just refining the mesh control for that fillet without taking to the other parts into account to impact on my result. And you see, I can even get the results to get closer. So that what we call it is the other method is when you want to use a specific control mesh for an area I believe is the weakest area. Now you say, why you choose that fillet? Why do you reckon? Why didn't you choose the top fillet or the back fillet or the other fillet? Why? Very simple question.
That's what we're getting at.
Because that where is the highest stress since we started this exercise. So I'm focusing on the areas I believe it could cause me issues. The other areas I'm okay. They are behind my maximum stress concentration. So mesh convergence doesn't occur at the what we call it the sharp corners. So if you remove the fillet and you try to investigate it on sharp corners, don't do it. Waste of time. We'll show you why to know why it's waste of time. Again, new study. Go to the default study again. Right click on the default study and make or copy a study and call it sharp corner. And please pay attention here because it requires some techniques here. Don't change, don't accept, don't do any other changes yet. So when you create a new study, don't accept yet. We still haven't done. Now, configuration use, no fillets. Change the configuration. No fillet should be. Is that configuration? Study name.
You're meant to accept it yet.
Doesn't have it? It's
I
okay.
have the option for.
Should be like this. You put default study, sharp corner, no fillet.
Let's get the fault.
It doesn't let you do it. And that's interesting. Sharp corner. Maybe click on it. Click on it, and then we adjust it. Click yes, and then double click on that. The sharp corner on the study. Yeah, right click, and then search for details. Properties. Let's see how can we do that one. No, double click on it, maybe it will tell us, with it. The sharp one, just go with that one.
Double click on.
Yeah. Double click. It's possibly something is still active. Review, down, activated it. Have you saved? Just save the project, maybe because it's not saved. So what we're doing is trying to change the structure of geometry to remove that fillet only from it. I'm just wondering, using the 24 version, right?
Yeah, yeah.
Using 24, using the 23. Should be. Okay, just let me do it. So default study, right click, copy study, and then you change that one, just type, type sharp corner. Under configuration, it's a license. I feel like it's a license. Okay, no problems. No, if you delete it, we'll ruin the design for you. No problems. You can save. And we do the cheap save. Don't create a new study. Save the project and close it. Save the project and close it. We do the normal slow way, since that way it doesn't work for your account. So save everything and close.
Close SolidWorks completely.
Close the applications and then not the SolidWorks, because we will open the part one, we save it again as a new, we call bracket 2. So in that bracket 2, we remove the fillet. You get my point?
Yeah.
Okay, so just to go through it. So save that project. No, we don't want to lose the things we've done so far to it. Have you saved it? Okay, then close it and close from here. Now you open Control N, part, and that part brackets, the one you had originally, before you save it, save as and call it part bracket 2. The reason, if we change the structure of the bracket, software will remove the old bracket and keep the new brackets. So we're creating a second bracket for this project. So save as a part 2 bracket or bracket 2. And that way you will not lose your first results or analysis with that. Have you opened the bracket? Where is it? No, you open the brackets we saved. We're not sketching a new brackets. You open the brackets, close this. Open, file, open, file, open. Save the bracket. Yep. Open. And now save as this bracket. File, file, file,
Original one.
save as, and call it bracket 2 now.
As a different, so you got 2 bracket files. Oh, no. Yeah.
Don't use space, use
Save
underscore.
as, file. Save as. Sharp.
So you just call it part sharp corner, anything. It's just we need to copy the brackets, but we copy it and save as, because if you save it, you lose the other brackets, the changes to it. So kind of we're creating a second file to do the analysis, okay? Right, so from that brackets, the fillets, I think was fillet 1, edit fillet, edit. No, you need to practice. And then that edge in the middle, and select the edge from the middle. So the remove fillet.
I find like I'm spending more time on SolidWorks than even the FEA. No, what are you doing? Fill it, right click on it, edit, yep. And now you have 3 edges, one of them should be removed. You need to know. Just remove them all and select it. Then you select the top one and the other one. The edges. Not that one, that way you wanted to keep it. Yeah, that one. And then accept. So you're just removing the edges. You can remove the 3 edges and reselect the other outside to keep just the one where we're interested in. Okay? Remove all the 3 and reselect the not that one. Edge, not face. So again, it's right so. Oh, you exit. So you can clear all selections. Keep that one and keep that one. Edge different from face. Okay. Done, Shivam? Okay, so now the problem is because see that is where give you the options, we'll give you a gray and then we activate it, but it didn't happen, so it's fine. We're going around it. Okay, now what we want to do, go to the, we set up the geometry again. So go to simulation, study, new study, static analysis, click OK. And then we go to material, remember alloy steel, right click on bracket, I'll apply edit materials, we repeat, alloy steel SS, apply and close. And then we go to fixture, right click on fixture, fix geometry. You select the circle to fix inside the surface. And then add, right click on external loads, forces, select that to add 900 meters. Are you there or you lost? So you start with static study, and now you select the, so we're repeating what we've been doing earlier. Yeah. And then apply and close, and then you come to fixture, fix geometry, select that face, and then external loads, forces, you select that one, type the value 900, and then click accept. So we kind of replicated. Now, the mesh is set to default. So you just create a mesh, right click on mesh, keep it like this, don't change anything, just click OK. That's the default mesh. Okay. Just click OK and run the results. It will give you now the brackets without it, which for me was giving 116 megapascal, the maximum at that edge. But you see, it's not anymore like that. So what we can do again, we do mesh control. So right click on the mesh and find apply mesh control. And from apply mesh control, I want you to use the following values. Change the ratio only to 1.2 for that edge. So first select the edge. You know, we don't have a fillet face now, we have an edge. You need first to right close, right? Click on mesh, apply mesh control. And then, yeah, the edge is already selected. No, that one, make it 1.4. Okay, 1.2, sorry, 1.2. And now you apply, run the results. Because when you see that, it means it's not run the result. Till you run the result, you get the maximum stress goes to 142 for me. I don't know for how much it's for you. Yeah, how much? 1.77. And then if you redo this step again, you go to edit the mesh control, you reduce it to 1 millimeter smaller,
you can see it goes to 192. So start going infinity. I start losing control from it. So give it a try. Try another number. Kind of, you go to the control, edit control. And then change the value to give you something.
I didn't have the same ratio this time.
Yeah,
Just change this one.
Yeah, just give it 1 instead of 1.9, make it 1. And then run the results. When you see that triangle, it means it's not running. Now, when it's run, it will take time. You see the number is jumped really hard. So what is telling me this? It means when I don't have the fillet, I'm going to infinity.
Yeah.
And that's inaccurate. That's wrong. That's the reason of fillets. And also from, because Shivam, you done fabrication. You don't leave this edge like that. Will break very quickly. So always you weld it, and we'll weld it will be kind of like give it this kind of a fillet of welding, right? Either that way or that way, depends on the use of the brackets. And that to strengthen it, to give it enough strength as a structure with the material properties to make sure will not be a weak area. So definitely, if we continue with this, every time we reduce the element size, the value of maximum stress increases. Definitely, this shows how fillets are important to reduce the internal stress experienced at corners in a model. Very important to use those fillets. Otherwise, we'll be going nowhere. Right. That's all done for the day. I have a quiz before you go. Before we finish the remaining of the things. Don't worry, we're not done. We're done as a demo. A mesh with a higher number of elements typically produces more accurate simulation results. True or false? True. Mesh convergence is the concept that as the mesh becomes smaller and smaller in area of stress concentrations, the maximum stress value will become more accurate. True or false? Which of the following meshing scenarios will create the mesh the quickest? Select the correct option. So chorus mesh with mesh refinement, fine mesh, all of the above takes the same amount of time. Chorus mesh is the faster one. We saw it 0, time. Perfect. Improving the mesh refinements of stress concentration at a sharp edge will lead to mesh convergence. True or false? False. We saw that it goes to infinity. We cannot even control it. The last question, adding fillets to sharp edges in a model will cause the stress to increase towards infinity. True or false? False. Because fillets, the opposite, they actually make it more stabilizing and getting to the true story. So all of this, the materials and the model and everything, we go to Moodle. And you find it, especially for the people from WIT. Oh, I lost my login. Let me share my screen. You share screen. So when you come to the topic FEA analysis, FEA single parts, you will come to this topic. You'll find the PowerPoint slides. And I put as well the mesh convergence long file there as well to try it. But you made it today. So all of these things, what we learned, if we sum it up, we sketch SolidWorks, a very simple sketch for a brackets. We revise a bit of techniques of sketching. We introduce how can we set up the static analysis FEA. We investigated stress concentration using von Mises, and we defined that equation and how it works. And the most important things is meshing. How can we refine the mesh to reach the convergence to make sure this acceptable results? And also the importance of fillets and how if we remove fillets, what will happen to my parts? And remember, we're doing one part. We don't have the other when it's assembly of contacts. And then you go through it. So everything is available under this Week02 notes examples. I'll pause the recording and Right, so to continue with the topic, now I'm just restarting my SolidWorks. Again, as I say, this material is available on Moodle. So my SolidWorks, I'll show you what I want you to do to practice more on this type of applications within tutorials. No, no, we're done for that example for the day. So the question is, I see people leaving. Yeah, okay, that's fine. So here, when you comes to new parts, we go always to simulation, but always I recommend to go to help. You come to this screen. I just want to make sure I'm sharing my screen. Yeah, I'm sharing. So help, tutorials. Also works simulation, tutorials. And then you come to, let's put this here. SolidWorks simulation professionals. We choose you something professional. No, that's multiple parts. Fatigue analysis link. That is multiple. I want single parts. I don't want multiple parts. It's multiple parts. We do them next time. I love this one. So we have this question. So you come to SolidWorks simulation premium. You come to the topic. Because we were introducing FEA analysis using strength of materials, but SolidWorks also, within studies, it's providing you different applications. For example, there is no geometry, doesn't like it. Different applications for heat as well. So that tutorial I want you to do now is this one, the geometrical and nonlinear analysis of a plate. Subject to pressure, not heat, this one. So there is sometimes we do a pressure. So I want you to do this. Would take about 15 minutes, but I would say 30. We'll go through it. So please open, help, you come here, SolidWorks simulation tutorials, you come to SolidWorks simulation premium, you start with this tutorial, description of the model, we go through it, and then you will open the file, and then you continue to follow the instructions, and then you do it step by step. Make sure to save the file when you start. This is the interesting, looks like a surface, so it's a 2D simulation, not 3D. Okay, and follow that. So again, what I want you to do, simulations, tutorials, and then you come to SolidWorks simulation. I want you to try this one, geometrical nonlinear analysis of a plate. Josiah, are you there? So if you're there, just give your in the comments. You can use the chat so I can know if you can access these things in your computer.
Yep.
Cool.
Yep.
And then that will take you. It says 15 minutes, but if you haven't done it for a long time ago, with maybe take you more than 15 minutes, and we go through it, and then we see if we're done. We go to another example and applications. Okay. If you know how to reach there, let me know. If you don't, I can show you individually. So you go to tutorials, you close what you've done so far, save everything. We're starting in new applications. Yeah, you can take a break if you want a break. It's fine. An airplane taking off. We'll go and get water. So Josiah, if you need anything, you can always talk, or just type in the chat if I'm moving around
Okay.
here, right? Yeah.
Thank you.
Getting water. I'm feeling.
Okay. Yeah. The one. Okay, so. Simulation is solved with premium. Yeah. Like.
Premium. No, you didn't go to the right tutorials, so go help again, question mark. And yeah, and tutorials. Then premium. Premium. Yep. And then reflect. Premium. And then reflect. Yep. Resume recording. So if you're done with this tutorial and you got all the results, that's really good. We're learning about the surface plan and how you add thickness to it. So I'll go again to the tutorials, SolidWorks simulation tutorials, and then you go to the premium one, try to do the elastoplastic analysis of a C-clamp, that one. Which is a good tutorial to show you different applications when you have different designs. So elastoplastic analysis of a C-clamp. Right, so that it's saying based on says 30 minutes, and then that's mean we're done with for today. So if you do that, I think it would take you more than 30 minutes, but try to finish it today for anyone who's starting. Reason we're doing only single parts, because we want to just focus on an application itself, and then next, let's see when we start based on the course outline. We will continue week 3 as well, single parts, and we do more examples. Sorry, assemblies we start in week 4. So next week as well as single parts with different examples. All right.